Hey, hvac text. We have this air handler here, and the reason of this for this call, the client said the motor is having a kind of a noise. There's a loud noise coming out from this air handler. This is a straight cool unit, so we have the condenser outside. It's not a heat pump or a communicating unit. So what I've done, I've turned off the 24 volt. I've turned the thermostat into the off position, and we are going to open this electrical compartment to see what should be the issue there. Okay, so there are some screws I already took out, so let's take this out. Now we are right here looking at this motor itself. You realize that okay, this is a direct drive motor. The motor is a direct drive, to be precise, 3-speed. That is why they actually cap this one, and leave it out, and they use only 2 of this, right? And also they have a capacitor here. This is 20 microfarad capacitor. That's going to give a torque for that motor to start. Now what I'm going to explain to you is the wiring, why we call this a direct drive motor. A direct drive motor is just that motor that when power gets into it, it starts running. You don't have, it's not ECM, electronic control motor. When it receives 240, it starts running, right? Depending on the speed you wire it. So these wires correspond to different speed, right? But they use this one, which I believe it's for the highest speed. This motor to run at the highest speed. Now, let's look at the wiring configuration of this motor. Let's learn something. When you look at this motor, they have connected 2 wires, this purple and this black wire. When you trace this black wire, you realize that it goes into this relay that is attached to this board. This relay, this black thing here, is a fan relay. This relay is just like a switch that is being controlled by this board. So whenever this relay says, hey, let 240 volt run, 240 volt will leave from here and goes into the motor. Sorry, 120, right? 120 volt. Now, when you see this one get in here, and you also see another black from here, this black wire goes into this terminal. Look at it. This black one goes into this transformer terminal. Do you see that? And when it goes to this terminal goes into this circuit breaker. That means 120 volt gets in here, and then they split it, pick it up, and brings it here. So at any moment, in as far as this breaker is on, there will be 120 volt getting here. So it's just like you pick 120 volt, one of these terminals, you bring it here. Now for this 120 volt to run through this relay that will now go into the fan, this control board need to control it. So this is like a switch controlled by this circuit or control board. Now that gives us one of the circuit. For the circuit to be completed, they also use this purple wire. This purple wire, you see, it goes back again into this transformer, which is also splitted. When you send it around, you see that it goes round into that electrical kit, but at the end of the day, it will come back to one of the terminals in this breaker, circuit breaker. So it's like picking one here. This one goes directly. So if I take this one, this purple, I unplug it here, I can send it directly here. That's the same thing, like sending it here. If I remove this black and send it here, this motor will run if it is working. That is a direct drive motor. It doesn't need any, there's no control, it's not an ECM motor, electronic control motor. It runs when there is 240 getting into it. So this is just a switch. This one is connected directly. This one is like a switch now. This switch is to send in 120 volt to complete the electrical circuit, which is 240 volt for this motor to run. So that is why they don't need this one, right? So if I also take one of these, depending the speed I want it to run, take this one out, this black, and put this one here, this motor will run in a different speed. It could be a slower speed, but I think this is the faster speed, the medium, and the slower speed. So we don't need the medium speed and the slow speed. We just need the faster speed, the fastest speed. That's why they use this one. So this is what I call a direct drive motor. Now, there are several ways to test this if this motor is working at this point. I can actually test it if it is working. What I'm going to do, first, I have set my hands here based on what the customer said. This is kind of stuck. It's actually stuck. The rotation is not good. The rotation is not good. That means that motor is not good. Now, for me to test this motor, I can definitely unplug this one. So I'm bypassing this switch, right? Take out this one, and I'll also unplug this one. Yes, unplug this one. Then I will look for a way to power it directly here. Take my 240 volt in one of these terminals, maybe one here and this purple the other side. If I do that and this motor is working, then it should run. It should be able to run normally. Okay, so that is a way you can test it. For now, we are not going to do that because I already know that this motor is bad just by rotating it. Sending my finger here to rotate that, the rotation is not good. So that motor is bad. So that is a way you can test that motor. Now, if you test this motor and it runs normally, that means your problem should be at the point of the circuit board. And you can also test this relay. What you have to do with this relay is just put the unit, turn it into the cold mode or to fan. Take one of the lead, right? Put it here and put one on the crown. If you don't have 120 flowing, that means this board or this relay is bad. You take one of your multimeter lead, you put it here because 120 volt must come out from here. When you put that here and you put one of the lead on the ground and you don't have 120 volt, means the unit is bad. So that is how you can actually test. With that said, guys, thank you for watching. I hope this helps and see you in the next one. Bye bye.